Hi, welcome to another video short. Today we're going to be examining continuities of functions. More specifically, we're going to determine where f of x, which equals x squared plus 2x minus 3 divided by x minus 1, we're going to determine where this function is continuous. Now, if we had a graph of this function, it would be very easy for us to visually determine points of discontinuity. But since we have a function, we're going to have to approach this by using some algebra. Now, the first thing you'll notice is that this function is a quotient of a continuous function divided by another continuous function. And if you can recall from one of the theorems, a function which is a quotient of a continuous function over a continuous function is itself continuous, except where the denominator equals 0. So this is the point of contention for this. Now, one of the things we have to do is to recognize, is this the only point of interest? The way to do that is to examine the function, and we're going to look at the function x squared plus 2x minus 3 over x minus 1, and we'll see if we can do any factoring. And my numerator factors out to x minus 1 times x plus 3. Therefore, my x minus 1 and my numerator and denominator cancels out. And this tells us that our function is equivalent to that of x plus 3, except we don't have a value when x equals 1. In other words, this graph is in fact a straight line, but it has a hole located at x equals 1. So we can actually answer the question, because the question asks us to determine where this function is continuous. So this function is continuous everywhere because it's equivalent to the line y equals x plus 3, except that our function has a point of discontinuity at x equals 1. And at x equals 1, we have a hole in the graph. So let me just bring up that graph for you so we can examine that. And as you can see, we have the line y equals x plus 3, except when x equals 1, we have a hole in the graph, so we have a discontinuity at x equals 1. Thank you for watching.